What's going on, everybody? Welcome on this bright and hot, sunny 4th of July. And I want to talk about something else other than 4th of July. As many of you probably know about via social media, there was a 6.4 earthquake in on the west coast, Southern California. And this will be a good time to talk about earthquakes and geology and plate tectonics. Just like it's a learning tool, so people actually can understand what happens, what's going on. It's a general overview. First of all, just happened not too long ago. I hope everyone is okay there. Hope no one was hurt. Hope no one was seriously injured or any kind of big harm came to people. But let's discuss what an earthquake is. For those who don't know, the Earth, the Earth is separated into different parts. Okay, you have the crust, which is the outer layer of the Earth, the part that we're on. That's the mountains, the land, the sea, the oceans, the rivers, all the stuff. That part is called the crust. Okay. Then you have the mantle. That is the layer below the crust. Okay. Then below that you have what's called the outer core. Okay. And then in the center of the earth, you have what is called the inner core. Okay. The inner core of the earth. What we're going to deal with now is the first two layers, mantle and crust. What people don't know, well, some people may not know, well, I'll say that, some people may not know is that the Earth's crust is broken up into large landmass. I'm not talking about continents, I'm talking about something larger than the continents. The continents are the part of the crust that are coming out of the water. Okay? But below the water, below sea level, like the floor of the ocean crust, is the much larger place they call plate tectonics, which are giant and enormous. Doesn't quite let you know how big these things are. But they're called plate tectonics, and these plate tectonics are they're kind of like puzzle pieces, jigsaw puzzles, right? You know how when you put puzzle pieces together and some fit, some don't. Well, with the plate tectonics, they're parts that they're pieces of the crust where like they move. What people don't know is the Earth's crust is in constant motion. It's always moving. Why, you may ask? I'm glad you asked. The plate tectonics move because the mantle, if I'm not mistaken, the mantle is, I don't want to say liquid, I say molten. But this, if you ever put like a flat, like you put like a few flat objects over a liquid surface. Well, what happened is the flat objects will move because the movement of the water or the molten rock, aka the mantle, is in constant motion. Therefore, the plates are in constant motion. Okay? When you put a solid surface over a liquid surface, the solid surface will move. Okay? So, the movement of the plate tectonics is what causes earthquakes. And you have earthquakes for different reasons. One, you have earthquakes because you may have an eruption, like a volcano eruption. Volcanic eruptions happen. And because of the volcanic eruptions, it shakes the ground, thus making an earthquake. Okay? Or you may have a movement in the plate tectonics. Okay? If you have two solid masses colliding together, there's going to be a collision, and that collision will cause an impact, and that impact will move things around. Okay? I don't know why I did this, but I'm just gonna do it anyway. So, the plate tectonics, because they're in constant motion, because they're on top of the mantle of the earth, they move around. And these large plates, these large land masses, were made of solid rock and iron and water on top of the plates. All these different solid objects. They move around and they bump into each other. And when they bump into each other, we say two or more objects cannot occupy the same space at the same time. Well, in quantum physics, that's different. But so like on a more macro level, two objects can't occupy the same space at the same time. When you have two or more masses occupying the same space at the same time, eventually one of them has to be moved. You will have resistance, and that resistance builds friction, and that friction creates a collision. That collision creates vibrations in the earth, in the ocean, and that vibration you feel is an earthquake. Okay? That's what an earthquake is. An earthquake is the result, it's the end result of a collision or an explosion. Explosion being like a volcano, or collision being the plate tectonics moving. Now, if you were to look at the map of the globe and look at the plate tectonics, right? All the continents have their own individual plate tectonic. You also have the plate tectonics in certain oceans, like the Pacific plate. If you look at because most of the earthquakes that happen in the United States happen on the West Coast, California, all that stuff. You'll have a few of them on the East Coast. I remember some years ago there was an earthquake. I think that happened in Pennsylvania. It was somewhere happened on the East Coast. I was living in Pennsylvania at the time, and we felt the aftershock. But most of the earthquakes that happen in the United States happen on the West Coast. Why? If you look at the surface, or if you look at the crust of the planet Earth without the waters, you will see these large lines in the crust of the earth. Those lines are kind of like lines of demarcation for the separation of the plate tectonics, right? And there is a large, it's called a ring of fire. I'll explain why. There's a large plate tectonic in the Pacific Ocean. And the Pacific Ocean is in between the western part of North and South America, and you have the East Coast, Eastern Asia, Japan, China, the Micronesia, Philippines, all that, and also Australia. It's called a ring of fire. That location is one big plate tectonic, and it is known for causing a lot of earthquakes in Japan and, more specifically, California. That is always moving because there's a lot of volcanoes there. As a matter of fact, that is where you get the Hawaiian Islands. People think that we think about Hawaii, think about those 5 or 6 islands that people vacation, but no, no, no. The Hawaiian Islands are a group of a group of islands that range like in the hundreds. Actually, there's more than just those 5 or 6 islands you see on the U.S. map. There's like 200 of them, and what happens is that ring of fire, that plate tectonic, that has underwater volcanoes. And what happens is when the volcanoes are erupting underwater, and some of them come above the ocean, come above the ocean, it makes new land. And if you look at a complete map of the Hawaiian Islands, you'll see a long line of islands ranging in different sizes. That is where the Ring of Fire is. Okay? Hawaii is on the west coast of the United States, in the middle of the Pacific Ocean. That Ring of Fire, that plate tectonic, is most likely what's causing the earthquakes in California. Matter of fact, it is what's causing it. It's what's causing the volcano eruptions in Hawaii. It's what's causing the earthquakes in California. If you were to go to that land area in the Ring of Fire, 9 times out of 10, if you were to check to see if there was a volcano eruption or an earthquake, chances are that will be the cause of the earthquake in California. If you could trace it back, because when the earth shakes, it travels. First of all, the earth is always moving. Therefore, it's always shaking. It's always earthquakes. The difference is every now and then you'll get some big ones. But if the earth is a large, if the earth's crust is a bunch of different solid plates of land, and it's moving on top of molten rock, there's going to be some rumbling. There's going to be some movement, some jostling, some vibration constantly. It's going to be. Now, we on the surface, on the very, very top surface of Earth's crust, may not feel it most of the time, but every now and then we will get a jostle from the bottom of from the Earth's crust that is strong enough and powerful enough so that we on the surface, the top surface of the Earth's crust, can feel it. What happened today was just that. An earthquake happened on the bottom of the Earth's crust, and it was strong enough for those on the West Coast to feel it and to visually see it, because they have what's called seismographs. Seismographs are what geologists use to measure the strength of earthquakes. Okay, and it's always moving. The crust is always moving, so there's always going to be small little miniature earthquakes that we don't feel. Every now and then, we'll get one that is registered on what's called the Richter scale. Okay, the Richter scale is what is used to measure the strength of an earthquake. So today was a magnitude 6.4 on the Richter scale. Okay, that's what they use to measure the strength of an earthquake. A 6.4 is enough for people on the top surface of the Earth's crust, i.e. us, or those on the West Coast in this particular case. A 6.4 is strong enough where you can visually see things happen. I just got finished watching a show, what's it called, The Herd, on Fox Sports 1, with Colin Cowherd. In the middle of his live broadcast on his show, The Herd, on FS1, you saw him on live TV move back and forth. You saw the camera move back and forth. It wasn't a visual effect. It was an earthquake. It was that earthquake that just happened, that it was strong enough so you could visibly see him move on live TV. And that's happened before. I think it was a baseball game like a long time ago, long time ago. Let's go. A long time ago, where a baseball game was interrupted because of an earthquake. All right, so check out for the Richter scale and check out that Ring of Fire area, and that should tell you where it happened, or they call it epicenter. All right, catch you all later. Peace.